Hello everyone. So today we will continue with chapter 4 chemical bonding, and we will continue with this subtopic 4.2 molecular shape and its polarity. At the end of the lesson, you should be able to explain valence shell electron pair repulsion, or I will call it as VESPER in short. And then draw the basic molecular shape. There are 5 basic molecular shape, which are the first one linear, second one trigonal planar, third one is tetrahedral, fourth is trigonal bipyramidal, and then the fifth basic shape is octahedral. And explain the shape of molecule and bond angle in a given species. Right, so what is the actual shape of this compound? Okay, so before this, you already learned how to write the correct Lewis structure. Okay, so that is why it is important for you to get the correct Lewis structure. For this formula, it is PF5. And then you need to identify the central atom here. So for the central atom, in this case, it is P, phosphorus. So this molecule, it exists as expanded octet. Okay, so you need to make assumption. Electron pair or bonding pair in the valence shell should repel one another. It will give the position of all the atoms here in space, how they arrange themselves in space. And then next, you will determine the molecular geometry. And this is all about VESPER, valence shell electron pair repulsion. Okay, so let's look into detail. Okay, so the important things that you need to know, molecular geometry is the 3D arrangement of your atoms in a molecule. So basically, it's how the arrangement of your atom in 3D lah. It will affect the physical and chemical properties of the molecule, and we can predict the molecular geometry by using this VESPER theory, or the full name is valence shell electron pair repulsion theory. So what are the theory? VESPER theory states that the valence electron, okay, so we will just focus on the valence electron pair surrounding the central atom only. It will repel one another. Okay, so these are the keywords that you need to highlight and bear in your mind. So, bonding pair, valence electron pair, it includes bonding pair and lone pair of electron. They will arrange themselves as far apart as possible. Mean bonding pair dan lone pair will arrange themselves sejauh mungkin dalam 3D space. Why? This is because to minimize repulsion. I will explain this in detail. Minimize repulsion. Okay, so you need to know that there are 3 repulsive forces. First, between bonding pair. So means sesama bonding pair akan ada repulsion. Next, between lone pair dan another lone pair. Or the third type is between bonding pair dan lone pair. Okay, so I will explain this in detail later. Okay, molecule can be divided into two categories. Okay, so what are the categories? The first one is the central atom without lone pair. So in this case, the central atom is carbon. Is there any lone pair here? No. And then the next category is central atom which has lone pair, either one or more lone pair. Okay, so first, look at the central atom. So nitrogen. There are lone pair here, one lone pair. So the next molecule is H2O. The central atom here is oxygen. So there are two lone pair here. Okay, lone pair ada dua. So in this ClF3, the central atom here is Cl and it has two lone pair. Okay, so we will focus on the central atom to determine the geometry. Okay, so let's have a look for this one, NF3. So you can see here. Okay, I will explain this in detail after this. So in NF3 molecule, there are one lone pair, but there are how many bonding pair? 1, 2, and 3. There are 3 bonding pair here. Three bonding pair. So it is important for you to identify lone pair dan bonding pair. Right, so as I mentioned before, there are 5 basic molecular shapes. So the first one is linear, trigonal planar, tetrahedral, trigonal bipyramidal, and then octahedral. So these are basic molecular shape. Okay, means it is without lone pair. Okay, so later I will show to you with lone pair. Okay, so let's have a look at the first basic molecular shape. Okay, so the first one is linear. So the class of the Vesper is AB2, means the central atom is A, bonded to one terminal atom and another terminal atom. So how many bonding pair? 1, 2. Okay, so number of atom bonded to the central atom ada 2. Number of lone pair at the central atom? No. For this case, the bonding pair between A and the first B and then A with another B atom will arrange themselves as far apart. So remember, they will the bonding pair ataupun the lone pair, in this case we ignore the lone pair first. Bonding pair will arrange themselves as far apart. Means susunan dia adalah sejauh mungkin to minimize the repulsion. Okay, so bonding with B atom here and one B atom is at another end. So the bond angle here will be 180 degree. Okay, so let's have a look at a real example. For example, BeCl2. Okay, so beryllium is one of berba. So it will be incomplete octet. So when you follow the order to write the correct Lewis structure, you will come to this structure. Okay, BeCl2. Okay, so beryllium as the central atom, Cl as the terminal atom. So you have two bonding pair. Okay, so one bond here, one bonding pair with another bonding pair, they will arrange themselves as far as possible. So the bond angle here will be 180 degree. Therefore, the arrangement of the electron pair will be linear. And the molecular geometry, we can call it as linear. Alright, so next we look at, okay, this is the example of the molecule. So there are two bonded atoms to the central atom and beryllium no lone pair at the central atom. Bond angle is 180 degree. Therefore, your bonding pair here will arrange themselves as far as possible, sejauh mungkin. Therefore, your atom will arrange themselves in a straight line. Okay? Right. So next, let's have a look at the next class, which is AB3. And the arrangement and the molecular geometry is trigonal planar. Okay, so AB3 means central atom A. There are three terminal atom. 1, 2, 3. Okay, so 3 atoms bonded to central atom ataupun there are 3 bonding pair of electron. Okay, so the arrangement of the bonding pair in 3D, they will arrange themselves as far apart according to Vesper. Therefore, your arrangement of electron will be trigonal planar and the molecular geometry will call as trigonal planar as well. And the bond angle here will be 120 degree. Okay, so planar means you can view it in plane lah, macam atas on a piece of paper. Okay, so the angle, bond angle for each 120, 120, and here also 120 degree. So for example, BF3. So BF3. So BF3, if you follow the way to write the Lewis structure, okay, you will come to this structure of BF3. Okay, so the bonding pair, sesama bonding pair akan arrange themselves as far as possible and the angle will be 120 degree lah sebab dia symmetry. Alright, so next let's have a look at next class, which is AB4. You will get the arrangement or molecular geometry tetrahedral. Okay, so macam mana pula AB4 ni? A central atom 1, B ada 4 kan? 1, 2, 3, 4. So ada 4 number of atom bonded to the central atom. 1, 2, 3, 4. Tengok kat sini. Okay. And then how you want to draw it? Okay. So imagine dalam bentuk piramid yang triangle base. Okay. 1 di atas and 3 lagi ni sebagai dia punya base. Okay. Later I'll show you the 3D structure. Okay. So for now, you just try and draw like this. So, according to Vesper, since ini adalah symmetry, all the bond angle adalah 109.5 degree. Okay, for each between this bond and this bond, to all this apply to all the bond angle. 109.5 degree as well untuk semua lah. Okay, so you can see here, okay, imagine dia dalam bentuk piramid yang triangle base. Okay, so satu di atas your terminal atom and the other three is as the base. Okay, so bond angle untuk semua adalah 109.5. Ini pun 109.5. This one also between this bond and this bond 109.5 degree. Okay, so you can view this in 3D lah. You can turn around, rotate all the molecule 360. Still the bond angle is 109.5 degree. Okay, so for example CH4. Contoh CH4 1, 2, 3, 4. Okay, so all the bond angle 109.5 degree. Right, so for the next one is AB5. There are 5 atoms bonded to the central atom, no lone pair, and the arrangement is trigonal bipyramidal. And the molecular geometry is also trigonal bipyramidal. Alright, so for the next class is AB5. So AB5 means ada central atom SA and ada 5B terminal atom. So first bond, second kita letak sejauh mungkin atas satu, bawah satu. And then the next one kita buat di atas planar. 1, 2, 3. Okay, dalam bentuk Y begini. Okay. So, the shape ataupun geometry is called as trigonal bipyramidal, and this is how we represent it lah, as molecular geometry. Okay, so why we call it as trigonal? So trigonal here means dia punya base dekat sini tapaknya dalam bentuk segitiga. Okay, so means here lah, dalam bentuk segitiga. And kenapa bipyramidal? Bi means ada dua. So piramidnya satu di bawah dan satu di bahagian atas. Okay, satu atas, satu bahagian bawah. Okay, that is why we call it as trigonal bipyramidal. Okay, for this case, kita ada dua angle. As you can see here, 90 degree is between sini, your bonding pair yang straight ke atas dengan yang planar. Okay, with all the planar. Semuanya adalah angle 90 degree. Okay, so dengan ini pun 90 degree. Okay, so imagine this as 3D. Okay, so another angle you can see here is between this bond yang planar. Okay, yang di atas segitiga ni lah. Okay, sini bondnya adalah 120 darjah. So between all the planar 1, 2, 3, ini semuanya adalah 120 degree. Okay, I will show you in 3D representation lah after this. Okay, so bond angle remember ada dua, 90 degree dan 120. So contohnya adalah PCl5. So kalau kita nak draw PCl5 begini. P as your central atom. Chlorine 1, 2, 3, 4, 5. Okay, don't forget to draw the lone pair at the terminal atom. Okay, make sure you draw the correct Lewis structure for each. Alright, so next, the last molecular shape, basic molecular shape is AB6 with 6 atoms bonded to the central atom, no lone pair here, and the arrangement of the electron, we call it as octahedral. Okay, so for AB6, how to draw it? Central atom A, B 1, 2, 3, 4, 5, 6. Okay, so mula-mula lukis yang paling jauh, atas bawah, and then the rest for bonding on planar. So we call it as octahedral. Kenapa octahedral? Sebab ada 8 surface and all the bond angle here all are 90 degree. Okay, so between atas dan on the planar, ini bond ini dan ini 90 degree, and between this bond on planar pun 90 degree juga. So the example here will be XE F6. So when we draw XE F6, XE F1, 2. Okay, so XE F6 ini boleh exist sebab dia adalah kategori expanded octet. And don't forget to complete your lone pair. Okay, so kalau tiada lone pair, salahlah kamu punya structure Lewis ni. Alright,